So welcome to another lecture. In this lecture, we'll be doing a brief outline of Venn diagrams. Now, Venn diagrams are very useful for looking at the set theory pictorially. So, for example, if I have a question like this, so let us assume this symbol, I'll be using this symbol again and again. In this lecture, the meaning of this Greek alphabet is universal set, and it is pronounced as xi. So in this lecture, the meaning of this would be universal set. So I was telling you about the power of Venn diagrams. For example, if I'm given a problem like this, x union y, x intersection y. So without Venn diagrams, it becomes a bit difficult to visualize. But using Venn diagrams, it becomes very easy. We'll see how it becomes easy. So there are few terminologies that you need to understand. Easy terminology. Once you understand the basics well, Venn diagrams is a beautiful topic because it's very pictorial. It's very easy to imagine. So it's a fairly easy topic. So the first symbol, if you don't know, we'll start from the simple thing. So this is the symbol of union. The mnemonic is this is U, so this is U, this is union. Uh, then there is an intersection. So this is the symbol of intersection. Now, whenever I draw a rectangle like this, basically what I'm saying is this is a universal set, xi. So universal set implies that whatever problem you are discussing, in that, what is the boundary? What is the boundary in which all the elements would be there? Now, in each question, the universal set would be different, depends upon the context. We'll take few examples and then you'll be able to understand well. So, if I have to represent union, because I'm discussing Venn diagrams, so I'll be using Venn diagrams to explain the concepts. So union would be all unique elements which would be there in two sets. You can have two sets, you can have three sets, however sets you want. But usually there are two or three sets. So for example, let us imagine there is a set A, there is a B, and there is a universal set xi. So for my purpose, let me define my xi as first 10 natural numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my universal set in this context. In this context, this question which I have formed, this is my universal set. Because at times students have confusion about the universal set also. Universal set depends upon the question, depends upon the context. It may change. Of course, it will change. So in this case, so for example, I am my set A is first three natural numbers. So I'll say 1, 2, 3, and my B is first five natural numbers. So this will be 1, 2, 3, 4, 5. So A and B sets have been defined like this. That A is 1, 2, 3, B is 1, 2, 3, 4, 5. Now, when I am writing the union, so A union B, it will be 1, 2, 3, 4, 5. Basically, the unique. Please remember this word unique. The unique elements in the set. When I say elements, elements imply the member of a set. So, for example, 3 is an element of set. So, A union B would be 1, 2, 3, 4, 5. Unique elements are 1, 2, 3, 4, 5. Now, if I say A intersection B are the elements which are common in both A and B. So, for example, in terms of Venn diagrams, elements which are common in both A and B would be these. So, in our case, this would be 1, 2, 3. So A intersection B in terms of sets, in terms of Venn diagrams is shown like this. So A intersection B, the common. A union B is both A and B. Both A and B. Intersection is common to A. So these are the simplest. I think more or less everybody understands that. Now we'll go to bit complicated. See, whole of the Venn diagrams is a pretty easy concept to understand. So that way, it's not concepts are not very difficult, but first time you might face some difficulty to understand. So now I am talking about A complement. This is how it is written: A complement. Now, if your A complement, if your theory is fine, you will understand that A complement is something. I'll show you in the Venn diagrams and it will become easy to understand. So, for example, you have a universal set. So, A complement would be all the elements which are in the universal set, but they are not in A. So, basically, this region. So, for example, in our case that we had done, my universal set is 1, 2, 3, 4, 5, 6 till 10, but my A is 1, 2, 3. So, I can't take 1, 2, 3, but rest of my A complement would be rest of the elements would be equal to 4, 5, 6 and so on till 10. So I hope this is making sense. So this is A complement. So now let's go to what's written here. This is A union B complement. So now in terms of Venn diagrams, how I'll represent this is A union B complement. So my suggestion to you would be to spend some time to understand Venn diagrams, and I can promise you this, that once you have understood the Venn diagrams, initially you have understood pictorially how the Venn diagrams looks like, then you can do any kind of question because it's a relatively easy topic. So remember that the rectangle represents the universal set. So you take A union B. A union B, as you understand, A union B would look something like this. So this would be A union B. So what would be A union B complement? So A union B complement would have all the elements which are not in A union B but are there in the universal set. So basically all these in terms of Venn diagrams, this would be our A union B complement. And in terms of our question, so for example, if in my case my A union B was 1, 2, 3. So in my case, A union B was 1, 2, 3, 4, 5. So in my case, my A union B complement would be 6, 7, 8, 9, 10. Now, I hope you are able to see that when I use Venn diagrams, how easy it becomes to find the value of A union B complement. It's a beautiful visualization technique. So we are done fourth disjoint set. The disjoint sets are sets where nothing is in common. So for example, we can have disjoint sets like in my case, my universal set is 1, 2, 3 till 10. So for example, here if I define my set C as odd numbers less than 10, odd natural numbers less than 10, and even numbers, set D as even natural numbers less than equal to 10. So C would be 1, 3, 5 till 9. D would be 2, 4, 6 till 8. Now these are disjoint sets. Why disjoint sets? Because they have nothing in common. So this is my A, this is B. They have nothing in common. So they are disjoint sets. So these are disjoint sets. Overlapping sets. This is how overlapping sets, like we have done before. So this is what is called overlapping sets. Now, for overlapping sets, this is how the A union B looks like. For disjoint sets, this is how A union B looks like. A union B, where B is a subset of A. So B is a subset of A. So that is why it looks something like this. So, for example, let us assume my C is 1, 3, 5, 7, 9. This is how I represented my C. Now let me represent my F. F is a subset of C and it is 1, 3. So I have defined F as a set 1, 3, which is a subset of C. So in my example, this would be the Xi would be the universal set. This is set C and this F is my subset of C. So hope this is also clear. Now let's move ahead. So basically what they are trying to show you is that first they have taken A union B. Then they have taken A intersection B. And they are trying to show you how do the overlapping set, for example in this case we did overlapping set, we did disjoint set, We did B is a subset of A. So now we'll be doing overlapping sets. So in overlapping, this would be A intersection B, common both in A and B. B is a subset of A. B is a subset of A. This is how it looks like. And A intersection Xi. So A intersection Xi. Basically, what I'm saying is, this is my Xi. This is my A. So what is common between A and the universal set? Of course, all the elements which are there in A would be common between A and the universal set. So this is how it is represented. I hope this is clear. Anything in the lecture where you face any difficulty, please comment below. I'll be glad to explain whatever doubt you have. You can mention the time where you face any doubt. I'll be happy to help you out. Now, shaded portion in the following region. So this shaded portion is A union B union C. So shaded portion in the sense that all of this. So all the elements which are unique in A, B, C. Unique. When I say unique, what I'm trying to say is that you can't take repetitive elements. So let me take an example, and because again this is one of the confusion that students have. So for example, if my one set is 1, 2, 3, 4, 5, and another set is 1, 2, 3, 4. When you are doing X union Y, you will write the 1, 2, 3, 4 only once, not twice, comma 5. So that is what I am saying. That is what I imply when I say that union is you take all the unique elements which are there in the 2 sets or the 3 sets, whatever they are. So there should be no repetition of the elements. You need to take care of that. This is A intersection B. This is A intersection B. Now A union B, A intersection B, union B intersection C, union A intersection C. Seems to be difficult, but very easy. Don't worry. I'll make this and show it to you. On the looks of it, it seems very difficult, but it's pretty easy. So see, this would be A intersection B. Yeah. So for example, this is A intersection B. Then I take a B intersection C. So let me draw a C here. The common between this is C. So the common between B and C. This is B intersection C. So B intersection C, and then A intersection C. A and C, the common elements. The common elements are these. So if you see, this would be the region. Because what you are doing is you are taking a union. Because you are taking a union, so that is why you will include all the three. But then there is an interesting thing that if you want, you can really think it through. If you want, you can really think it through. That if this is A, this is B, this is C. Now I want you to think about this. That this area is basically all the elements which are common in A, B, and C. So these would be those elements which will be there in all the 3 sets. So let's take a simple example: A, B, C. Let us say this is 1, 2, 3, 4. B is 2, 3, 4, 5. Or let me say this is 4, 5, 6, and C is 4, 7, 8. Now if you see, 4 is the common element which is there in all A, B, C. Hope you are getting it. Okay, then let's go to the next part, shaded portion in a joining of A minus B. So A minus B, let's look at in terms of Venn diagrams. So this is my universal set. What does A minus B imply? What A minus B implies is, so for example, I'll explain you this photograph which is drawn here. So what that A minus B implies is that you take A. Now from A, if there is any element which belongs to B also, then you take that out. I'll form a small example and then we can discuss. So for example, A is 1, 2, 3, 4 and B is 3, 4. Now what would be A minus B? So from A, from A, take out the elements which are there in B also. So 3, 4 are there. So take out those. So that is how A minus B would look like. So A minus B, basically the answer would be 1 comma 1 comma 2. 1 comma 2. So basically this is what A minus B will look like. Again, that, so B minus A, again, from B, you take out whatever elements which are there in A. So that would be B minus A. Now look at this. A minus B union B minus A. You take A minus B, this portion. You take B minus A, and then you make a union of that. Union means you collect all the unique elements, all the elements which are there in A, there in B, but there should be they shouldn't come twice. That is what I am saying when I say. Okay, I'll explain an example to you, and then we'll do a unsolved question also. So my so the number of universal elements are 73. In the universal set, the number of elements are 73. Number of elements in A is 39, in B is 37. Then they have given us A intersection B is 11. So they are asking us to find all these. They are asking us to find all this. Let me zoom it so you can see it properly. I think now you'll be able to see. Now you'll be able to see. So, for example, in my case, in this case, I have A intersection B. This is my universal set. So, number of elements in the universal set are 73. In A are 39. A are, so this one is 39. Let me draw it here. So, it will become easier. Now it will become easier to see. So universal is 73. A is 39. This is 39. A complement, sorry, B is 37. And A intersection B is 11. This is 11. Now see, 11 are the common elements in A and B. So you will have to write the name of A, B, universal set. Okay. Now 11 are common between A and B. Now if you are able to think it, and if you have doubt, please ask me in the comments. So if this is 11, only the unique, if I have to see in A, they will be 28. Why? 28 plus 11 is 39. So 37 are there in B, but the common between A and B are 11. So the unique in B would be 26. So basically what I'm trying to say is, in terms of my terminology, A minus B, number of elements of A minus B would be 2. Number of elements of B minus A would be 28, and this would be 26. And this 11 is basically A intersection B. Number of elements in A intersection B. This is 11. In terms of my set terminology, this is what it implies. Now let me look at the, basically, okay, let's ignore the question for a while, and I'll share some other things here. So for example, now if I have to see the number of elements in A minus B complement, or number of elements in B minus A complement, or number of elements in A intersection B complement. So see, leave all the elements in A minus B and consider rest. So that would be equal to 73 minus 28. 73 minus 28. B minus A 73 minus 26. A intersection B complement would be 73 minus 11. I hope you are getting it. So from the universal set, you take out whatever, because complement you take whatever is there in your set. This is what it implies. So if you want the answers, this would be 30, 43, 45. This would be 30, 43, 47. This would be 60. So these would be the answers of the question which I am asking. Let us see what is being actually asked in the question. So they are asking you about A intersection B, So number of elements in A union B, I'm sorry, A union B. Let us find A union B. So A union B would be 28 plus 11 plus 26. So this would be 37. So this would be 65. So A union B is 65. Now I don't know whether this is being asked or not, but let us say A union B complement. This would be 73 minus 65. So this would be 8. So basically, if you try to understand, so there would be some, 8 elements sort of which are not being there either in A or in B. So there are 8 other elements which are there in the universal set, but they are not in A and B. So try to think about this. So n of A complement would be universal set minus whatever number is there in A. So if universal is 73 minus whatever is there in A. So A was 39. If you had to find n of B complement, that would be 73 minus whatever there in B, 37. So I'm adding a lot of extra questions also so that you really understand what is going on. N of A minus B we have calculated. N of A union B complement. A union B complement. All you guys who are paying attention, you would have understood that A union B complement would be 8. So number of elements would be 8. So this is the example 9. Beautiful question. So I hope this is a pretty long lecture. I hope this was useful for you. We did theory also. We did a lot of questions also. And still, if there is any doubt, please let me know. And if you found this useful, please do like, comment, share, and subscribe for more such detailed videos. And best of luck for your future and best of luck for your exams. Yeah, let's meet again.